find the sum of the first 35 positive integers. So this was, I think, yeah, it was a while ago. I showed you a solution. I mean a formula, which is the sum of the arithmetic sequence.
Yes,
And
it's also an arithmetic sequence.
yeah, because no, the first positive even integers is 2, 4, 6, 8, and so on. So the answer here is 1260. Let's see how he guesses it. But you could try that. I
Yes,
think
you
it
can
works
try
in a
calculating
calcu.
it manually. 2 plus 4 plus.
Plus 6
See
plus
the
up to 70. Oh man. Oh, Daniel, Daniel,
That's
Daniel,
what?
Daniel.
What?
How did we figure out that the 35 the wait, what? The 35th term is
Positive even
70?
integer? Well, because the first positive integer is 2, right?
Yeah.
Then the second is 4.
Yeah?
So the 35th is 2 times 35. Or you may
Wow.
count it. You may count it on your hand. 2, 4, 6, 8, 10 until you reach the 35th.
35th term, oh man. Oh, what? Obviously, this is really tedious. Imagine adding 35 numbers. I don't even think it will fit in a calcu. In a scientific calculator. Oh man.
That would be really hard. Okay,
Observe. Alright, alright.
so here's another solution. Well, this is what Kevin is trying to present earlier. Kevin, you may present it.
Alright. Observe that even integers follow an arithmetic sequence. An arithmetic sequence basically means that they have a common denominator. I mean, what? A common difference
Common
between them.
difference.
Common difference between them. So 2, 4, 6, 8. What we can see is that the numbers are separated by 2. Right, Daniel? That's why
Yes,
they're called
4 minus 2 is
even
2.
numbers. Yeah. And we
6
can
minus 4
express
is 2.
that difference. I mean, we can using I mean, knowing that, we can know that the, to to find the term of an arithmetic sequence, we can use this formula. A1, which is the first term, plus n minus 1 times d will let us find the nth term of a sequence. So, looking into this, we will know if we substitute in the formula, right, Daniel? 2
Yes.
plus, we're looking for the 35 term, right?
Yes, 35th
2
term.
plus 35 minus 1 times 2 will get us 70, right?
Yes.
But that formula is just determining the nth term of a sequence. What we're trying to find is the sum of the whole arithmetic sequence. So we'll look into this. This is basically the simplification of the formula, which will end us with this formula. Oh, Daniel, do you want to explain this? Because I
Should I?
certainly can't. Yeah, you should.
Okay, okay.
All right, all right,
You go to the last slide.
all right, all right, all right.
Go to the, no, last slide.
Last slide.
The start of solution 2.2.
Oh, okay,
The past slide.
there.
Okay, so what we did here is that we first let S be the sum of the first n terms of the arithmetic sequence. Kevin, are you following me?
Yes, 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 yes.
Okay, so if we write out the terms, you will get a sub 1 plus a sub 2 plus a sub 3 and so on up to a sub n minus 1 and a sub n. Then, using the expression for the nth term of any term of the of any term on the arithmetic progression, you get that a sub 2 is a sub 1 plus d, right?
Yep.
Then a sub 3 will be a sub 1 plus 2d. And then, if we write everything out, a sub n minus 1 will be a sub 1 plus n minus 2 times d, plus a sub n now will be a sub 1 plus n minus 1 times d.
Mm-hmm.
Note that we only use the expression for the nth term of the arithmetic sequence here. We just wrote it using a sub 1 and d's and n. Okay, so next slide, Kevin. we just write it here again so that you can see the expression earlier.
Alright.
Then what we are going to do is that we will reverse the order of addition. So instead of starting with a sub 1, we will start with a sub 1 plus n minus 1 times d. And then next will be a sub 1 plus n minus 2 times. We can do this because addition is commutative in the plane of real numbers or in the set of real numbers. So if we add this term by term, next Kevin. So if we add this term by term, we will get 2s because s plus s is 2. Then if we add a sub 1 plus a sub 1 plus n minus 1 times d, we will get 2a sub 1 plus n minus 1 times d. And then a sub 1 plus d plus a sub 1 plus n minus 2 times d will give us yet again with 2a sub 1 plus n minus 1 times d. So you can continue this process and then you will find that all of them will be 2a sub 1 plus n minus 1 times d. Yes, and you can simplify them because you have exactly n of these. So we can just multiply that by n.
Yeah.
Then divide by 2, so you'll get s. And then here, if you separate 2a sub 1 to a sub 1 plus a sub 1, you can notice that a sub 1 plus n minus 1 times d is yet again another a sub n. So that will lead us with the formula that Kevin presented.
Yeah?
Yes, this formula, Kevin.
Oh, yeah. It led us
This
to
is
the
the
same
one that
formulas
showed-
before, yeah.
Yes.
Wow.
So that is how we can formalize the
sequence.
the derivation of the formula of the arithmetic sequence.
Alright, that's really cool. So, now how do we
So-
use this formula in order to solve the question? Obviously, we just substitute it in, right?
Yes, that's right, Kevin. So you'll just substitute.